a little bit hard for me to read. What is that number right there that I'm pointing at?
It is -2, I think. It goes from -1, -2, -3.
Okay, you can see why I'm having a hard time reading it. Are you looking at the paper?
I'm looking at my copy.
Okay. Can you read your copy any better than I can read it on the screen here? Is it -2? That's fine if it is, but I want to make sure that it's -2.
Yeah, it's -2.
Okay. So let's label that -2. And what's the y coordinate? That's off my page entirely, so I can't read a grid, the vertical grid.
I can send another one to you real quick if you like, so you can get the whole thing.
Yeah, that's fine. Although I can make out most everything else. This is the only problem where I can't read the right-hand grid. Can you read it and just tell me what this y value is?
Yeah. The y value is, well, the point, or x-intercept and y-intercept is at 0, 0.
Okay. But go ahead and send another page to me.
Okay.
That whole thing so I can see it.
So would you like just the graph, or?
That'll work, although then I'll have to switch back and forth. If you just move your camera slightly over a half an inch to the right where I pick up the whole graph, and make sure you pick up the numbers on the left. You're just using a cell phone, right, to take pictures of this?
Yeah.
Okay.
All right, I sent it.
Okay. I didn't get the second one. Got the first one earlier. Did you send it to David Cowan, 1949?
Yeah.
Don't think it went through. Let's not spend our time worrying about that. Just if you can just read that point to me off of your page, we'll be able to get on with it.
So that point is at -2, 4.
All right, that's all I need.
Okay.
So that is -2, 4, and that is the vertex.
Yes.
So if I'm trying to write an equation of that, what's the vertex format, the general?
Y equals the general. Y equals a x minus h, or p. I think it's h. Okay.
When you're in the vertex format, it's h and k.
Okay, plus k.
In the X-Intercept format, it's p and q. The k is the same regardless of which format you're in. Now, h and k are the vertex. So how much of this equation do I know at this point?
So you know the h and the k.
Okay, so tell me what to write.
So a equals, or y equals a x minus, or plus 2, sorry, squared plus 4.
Okay. Now the only thing I need is a, and I will have the equation that they're looking for. But I do need a point for a. Well, there's a point that I can see. Is that minus 4?
Yeah.
Okay, so I know that when x is minus 4, y is 0, correct? The point I just circled. X is minus 4 and y is 0. So let's put that in. Y is 0 when x is minus 4. And that's going to let us solve for k, or for a. Well, minus 4 plus 2 is minus 2 squared is 4. So I get 4a equals minus 4. I get a equal minus 1. Now, go back up to that equation, substitute minus 1 for a. In other words, I now have everything they want. And I can just put a minus sign in front of that. I don't need the 1. And that's the equation that they want.
Okay.
And it happens to be in vertex format. But that's the easiest equation to come up with because we're looking at the vertex. So we can come up with the vertex really easy. And then we just have to solve for a. Okay. So let me erase everything below this so we can go to part B. So if that's the equation, what I have in the rectangle, what transformations could you apply to the equation of this quadratic so that it has no real solutions? Write the equation of the new quadratic. Well, let's talk about what constitutes no real solutions for a quadratic. If I have a quadratic like that does not cross the x-axis, that has no real solutions. It's only imaginary. If you try to solve such a quadratic, you'll get imaginary solutions. Okay? Another example of a quadratic that wouldn't cross the x-axis might be this one or this one. In other words, any quadratic that does not cross the x-axis has no real solutions. So what would we have to do to this quadratic that we're looking at on the graph to make it so it doesn't cross the x-axis?
You can do...
Do I have to move it up or down?
Down.
Correct, because I can move it up as far as you want. It's still going to cross the x-axis twice.
Right.
But if I move it down to some place like that, then it does not cross the x-axis. So how many would I have to move it to get it approximately to where I have it now?
5. Down 5.
So, and that is a vertical shift of 5. In other words, if I add a vertical shift down of 5 to this curve, doesn't change the shape of the curve, as all it does is moves it down by 5 units only. So the equation of that is the same as what we just had, only I'm going to move it down 5 from what we had, which gives me a minus 1. In other words, what I have circled is what I have in the rectangle down 5 units.
Right.
So I could have moved it down 6. And that would have been minus 2. I could have moved it down 7. That would have been minus 3. So there were literally an infinite number of solutions.
Cool.
Okay, number 9. Now we're talking about projectile motion. Anytime you throw a ball, whether it goes straight up in the air and straight back down, or whether you throw it at an angle, it is going to follow the path of a parabola. If you kick a football, it's going to follow the path of a parabola. If you hit a baseball, anything that is contending with gravity ends up with the path of a parabola. Now, they're telling you in this experiment that Caleb threw a ball straight up towards the ceiling at a velocity of 16, and this function represents the height at any point in time, where t is in seconds. You with me?
Yes.
What's the height at 0 seconds? Plug in 0 for t. What do you get?
0.
Does that make sense? That the height of the ball is 0 at 0 seconds? Yes. That's perfect. Yeah. That confirms our model. Okay. So the first question says, the ceiling of the gymnasium is 60 feet high. Will the volleyball reach the ceiling of the gym and explain? Well, that means, is there a solution to this equation? 60, the height that they want it to get to, is there a solution, a real solution to that? Well, if I turn that into a standard quadratic, move both of these t terms to the left side, I get this. Now I got to see if that has a real solution. Well, what's one way to figure out whether it has a real solution without actually factoring it? It's called the discriminant. In other words, I suspect I probably cannot factor that just because I suspect that it won't hit the ceiling ever, which means there is no real solution to that. And I can prove that there's no real solution by analyzing the discriminant. The discriminant is the part of the quadratic formula that's inside the radical.
Right.
So analyze that. If that's a positive number, there is a real solution. It will hit the ceiling. If it's a negative number, then there's only imaginary solutions, and it will not hit the ceiling. So what's b squared?
6 or negative 16 squared.
No, it's not negative b squared. Here's the entire quadratic. If we had to solve that, that's what we would use. We don't have to solve it to answer this question. We just have to know what the discriminant is. And I suspect it's going to turn out to be negative, and that answers our question immediately. In other words, we don't have to go to the trouble of solving it. We just have to analyze the discriminant. So it's b squared.
16 squared
minus 4. A is also 16. And C is 60. Which is bigger, that or that? You can use your calculator if you need to.
And the -1 times 16 times 60 is bigger.
So the discriminant is negative.
Right.
It's less than 0. That's all we need. We don't actually need to know what it is. We just need to know it's less than 0. That tells us that this quadratic has only imaginary solutions, which means it's not going to hit the ceiling. Because they told us the ceiling was 60 feet high, so I plugged that in for h of x, with
Right.
h of t. H of t is the height. So I plugged in the height of the ceiling and see if I could solve that solution, that quadratic. And I couldn't.
Okay.
Now, let's see what else they're asking for here. Later, his friend throws the ball straight up, only with a higher initial velocity. Notice Caleb's initial velocity was only 16 feet per second. His friend throws it at 80 feet per second. So his friend's equation is minus 16t squared plus 80t. Notice that the coefficient of the t term is that initial velocity.
Okay.
In other words, whatever velocity you throw it up with makes the coefficient of that t term higher.
Okay.
Now, which changes the function? Will the ball reach the ceiling now? Well, again, the ceiling is still 60. So I'm going to plug in 60 for the height. And now I've got a different equation to try to solve. Now, notice b is much bigger. Negative, though. Now tell me what the discriminant is.
80 squared minus 16 times 6, or 4 times 16 times 60.
Now, which is the bigger number? That's 6,400. What's this number here?
Negative 3,840. So the other one's bigger.
Which means the discriminant is positive. If the discriminant is positive, it means I've got two real solutions to this quadratic. Now, let me take that back a minute. Look at this a slightly different way. The way I did both of it is correct, and it will definitely answer the questions they're asking. But I'm not sure that it explains it as much as if we actually find the vertex of that. Notice that that parabola, I can figure out the vertex, right? The vertex is minus b over 2a. Well, what is minus b over 2a? And I can either figure it out in that format or directly in that format. It doesn't really matter. In other words, when you're looking at minus b over 2a, that is going to be the same if I put those on the left side of the equation or the right side.
Okay.
So what is minus b over 2a?
So negative 80 over 16 times 2.
Negative 16 times 2. So it becomes 80 over 32. Regardless of how you do it. Regardless of whether you're on this side of the equation or that side of the equation, doesn't change minus b over 2a. Okay?
Okay.
What this tells you, the axis of symmetry, tells you what that value is right there. And in our problem, that value is 80 over 32. Okay, about 2.5. Now, question is we know that's where it's going to hit its maximum height. So if I go back to my original function and plug in this value for t, I can tell what the height it actually gets to at that time. And so here, I'm going to write it down here on the left. The true height that it gets to at time 80 over 32 is minus 16 times 80 over 32 squared plus 80 times 80 over 32. If we do that math, we will notice that the number we get is higher than 60. As long as it's higher than 60, it's going to hit a 60-foot ceiling, right?
Right.
So that's really the way to prove that it hits the ceiling, is to figure out where the vertex occurs by using minus b over 2a. And once you figure out what the t-coordinate of the vertex is, then plug it in to your original equation and you can figure out what height it's going to hit at that time. And I don't know what this is. You can do that on your calculator if you want. Kind of a pain in the butt to do on your calculator, but you'll get a number that's greater than 60.
Okay.
Which tells you that it'll hit the ceiling.
Okay.
I guess you'll get a number greater than 60. Let's do that math. Up here in the upper left. So I've got minus 16 times 80 squared over 32 times 32, 32 squared, plus 80 times 80 over 32. Well, notice that that's, if I take away that 16, it takes away half of one of those. And now, if I want to leave a 2 out there, in other words, I can put this 2 outside so that it's minus 1/2 times 80 squared over 32 plus 80 squared over 32. That is 6,400 over 32, but this one is being multiplied by minus 1/2, and so it's half of 80 squared over 32, which is 6,400 over 64. That's exactly 100 feet. The height of the vertex is 100 feet. Unless I made a mistake in my math. But that means that it would definitely hit a 60-foot ceiling.
Okay.
All right, let's look at number 10. Okay, it's asking you to stake the parent function, which is y equal x squared, and perform this transformation on it. Do a vertical stretch of 5, translate it 6 units to the left and 9 units down. So my new equation, which I will call g of x, is equal to what?
So 5 times x use left, so plus 6 squared minus 9.
Perfect. Number 11. Write the equation of a parabola that has those two things. Well, when you know the X-Intercepts, what's the best format to use? There's 3 formats. There's Vertex Format, which is probably the most common. Second most common is Standard Format, which they usually give you when they give you an equation. But the third most common is Intercept Format. Intercept Format, that A is the same as our other A, but the format is different. P and Q are the X-Intercepts. So how much of this do we know?
We know the P and Q.
So read everything we know. We don't know A yet.
Right. X minus, minus 3. And then x minus 9.
Okay, now they tell us that it goes through that point. What can we solve knowing that?
The x and y.
No? Your final answer, you need an x and a y in it. The final equation of a parabola has the x and the y in it. What we need is A. So we got to calculate A. But the fact that it goes through this point means I can substitute 8 for x and 4 for y, and that will allow me to solve for A. In other words, notice what I'm doing here. Just substituting the point values into my equation. Now, look, that's all I got is numbers and 1 letter. So that's not going to be any problem solving for A. Tell me what the next step is.
So simplify the parentheses.
Okay, so I got 4 equals 5 times minus 1. That's minus 5A. So what's A?
4 over 5.
4 over negative 5? Or how about minus 4/5?
Yeah.
Now, what's the equation that they want?
Y equals negative 4/5 times x minus 3 times x minus 9.
Notice the process was quite similar to an earlier problem that we did, where we were able to solve for h and k in the previous problem, and then we used the point to solve for A. Well, that's what we're doing here, is they give us P and Q, but in order to solve for A, we have to use the point they gave us. And you plug that point in for your X and your Y value. Okay? Now, the second part of that question. Has a y-intercept of 8 and a vertex at minus 1, 3. Well, let's use Vertex Format.
Okay.
What is Vertex Format?
Y equals A times X. Yeah.
Keep going. It's you that needs to memorize it, not me.
X minus, or plus 1.
X minus h squared plus k. Remember,
Okay.
h and k are your vertex. So whenever you're talking vertex format, you need the h and the k. If you're talking X-Intercept format, you use p and q. And if you're talking standard format, then you just put ax squared plus bx plus c. That's standard format. The only reason I chose vertex format here is because they gave us the vertex. So how much of this do we know?
The vertex, so x plus 1 squared plus 3.
Now, they say it has a y-intercept of 8. So what does that mean? In other words, I'm back to having to solve for a. Do I know a point that it goes through that I could substitute for x and y? And that would allow me to solve for a?
Yeah.
What point is it?
0, 8.
Yeah, and incidentally, you cannot use the vertex. You'll find that doesn't allow you to solve for anything. It's true that it goes through that vertex, but if I substitute that in here, I'm going to have 0 times a. So I'm not going to be able to solve for a. So you have to find another point. Well, it gave me 0, 8. So what's the next thing I need to write? I solve that for a, but I know an x and a y point.
Right. So 8 equals a times 0 plus 1 squared plus 3.
What's a equal to?
2.
What's 1 squared?
1.
So I got 8 equals a plus 3. What's a equal to?
Um, 8 over 3.
8 minus 3.
Oh, right. Okay.
So
5.
a equals 5. Now what's the equation? What's the answer to their question?
So y equals 5, x minus or plus 1 squared plus 3.
Okay. So that's the third problem now, where we were able to figure out everything except a by just starting it off in a normal fashion. And then you figure out a by finding another point. And in both of these problems, in part A, they gave us the point, and in part B, they gave us the point also. They just gave it as a y-intercept. So you had to do a little bit of thinking with part B's to know that the x value is 0 when you're on the y-intercept.
Right.
Okay. 12a, which way does that parabola open up? Does it open up or down?
Up.
Why?
Because the a is positive.
Good. Graph the equation including at least 5 points of accuracy. Where do I start?
So you can do the vertex.
Okay, where's the vertex?
3, 4.
Okay, I'm going to put that right there. That's 3, 4. Opens up, right?
Yes.
So I know it looks like that. So there's no x-intercepts. So the next 2 points I'm going to find are those 2 points. How do I get the y-intercept? What do I plug in for x to get the y-intercept?
0.
Okay. So what's y equal to when I plug in 0 for x? I get minus 3 squared plus 4. So I get y equals 4.5 plus 4, 8.5. So that value is 0, 8.5. Well, that's going to help you come up with that value. What's that value?
That's 6.
6, what?
8.5.
Okay. Now, there's no other critical points on this thing. Normally, we would go for the x-intercepts, but there aren't any. So if she wants 2 more points, just make up a value for x. And we'll figure out what y is. I've got my equation. So pick a nice convenient value for x that will allow us to figure out what y is. It's the easiest one to use. You can't use the vertex. Let's try 4.
Okay.
See why 4 is such a perfect number to use?
Yeah.
Because it makes that 1 squared. So when x is 4, what is y?
Y is 5.
What's 4 minus 3 squared?
-5.
What's 4 minus 3 squared? What is 4 minus 3?
1.
What's that squared?
1.
What's that multiplied by 1/2?
1/2.
Okay, so that's 1/2 plus 4, that's 4.5. So when x is right there, x is 4, y is 4.5. Now, I've got 4 points, but I know there has to be a symmetrical point over there. So what must that value be? We know the y value is 4.5, right?
Right.
It's my x value of the pink on the left. In other words, it's the same distance from the vertex, right? Horizontally?
Yeah. So 2.
You got it.
Yeah.
In
Okay.
other words, my 4th point that I found was 1 unit to the right of the vertex. So this other point, my 5th point, is going to be 1 unit to the left of the vertex, where my y value doesn't change, so I don't have to do much math to find the 4th and 5th points. And I didn't have to choose those points. I could have found points up here. Same way. In other words, when you're trying to find 5 points, you can pick them anywhere you want, unless she specifically asks. Now, with a typical parabola that has x-intercepts and a y-intercept, all of them have y-intercepts, but only some of them have x-intercepts, she's going to tell you what is the y-intercept, what are the x-intercepts, what are the vertex, and that's where you get your 5 points from.
Right.
There's really not much reason to ask for 5 points of accuracy when it doesn't cross the x-axis. These 2 points in red aren't important points on this parabola. There's really only the key points on any parabola is the vertex, the y-intercept, and the x-intercepts. Well, this doesn't have any x-intercepts. So asking for 5 points is a little silly, but don't tell your teacher I said that. Okay, I guess I can't scroll up any further. So, 13. The shape of a bridge support can be modeled by that. Well, what is that? That is a quadratic in Vertex Format. Let's draw a picture of this bridge. There's the support beam. Here's the bridge. Its support system is in the shape of a parabola that points down, right? Do I
Yeah.
see an audio? It felt like I might have lost the audio for a second.
Yeah, I just got reconnected.
Okay. Here's the model of our bridge. The black line is the bridge. The pink curved quadratic parabola is the support for the bridge.
Okay.
And I know that it's like this and not underneath in the shape of an open parabola because of that -6 over 125. That tells me that it's a parabola that opens down. So the only way this picture can make sense is if the support for the bridge is above the bridge in the shape of a parabola.
Okay.
The height at any point in time is the height of the support above the bridge deck, right? In other words, it's this distance right there. That is h of x. So let's do one thing here. Let's draw our picture so that the left end of the bridge is at the origin, which is always not a bad way to go. It makes the math easier. There's our bridge now. Okay? Now, draw a picture to help solve. From the given function, state the vertex and find the x-intercepts. Well, the vertex is pretty easy. What's the vertex?
50, 120.
And what that means is that that's 50, and that's 120. Find the x-intercepts. The way I drew this, I've got one x-intercept at the origin. So my picture may not be quite right. I may have to redraw the picture. If I calculate the x-intercepts and they don't end up to be at 0 and whatever that point is over there, which would have to be 100, then I've done something wrong with my picture. Isn't quite right. So how do I figure out the x-intercepts from this function right here, which is in Vertex Format? In other words, it's not in X-intercept format. I can still figure out the x-intercepts. What do I have to set h of x equal to?
0.
Correct, because that's what the height is when I'm on my x-intercepts. Regardless of where they're at horizontally, my h of x is going to be 0. So over up here in the left, I'm going to set h of x equal to 0 and solve this equation.
Okay.
Figure out where these intercepts are, and then I'll be able to draw the picture better. Okay, so what's the first step in solving this equation? Got this equation right here, and that square is inside there.
So add or subtract the 120.
Keep going. Next step.
All right, so then divide by -6 over 125.
Okay, which is the same as multiplying by its reciprocal.
Right.
So I'm going to multiply everything by that, the left side by that. And when I multiply the right side by that, I get x minus 50 squared. That's what's left.
Okay.
Now notice they used some convenient numbers here, so I can take that out and make that 20. 20 times 125 is 2,500. So I've got 2,500 equals x minus 50 squared. Solve that.
Square root 2,500.
So that's plus or minus 50 equals x minus 50. So what are my two values for x?
X equals 0 or x equals negative 100.
So my model here is almost perfect.
Yeah.
Except I need to shift it horizontally way to the left so that my bridge is over here. And that is at minus 100. That is at 0. I don't think so. Our vertex was at 50. Our vertex was over here. I think we made a mistake in that math. I think our x-intercepts were 0 and 100, not negative 100.
Okay.
Not sure how. I don't really like going back and figuring out where I make arithmetic mistakes. But we can tell it's got to be on the right side of the y-axis. Because it has a vertex that's positive. In other words, the vertex is clearly 50 plus 120. That's over here. And we are definitely going to find the x-intercepts by setting that equal to 0 and solving, but I guarantee you if we do it again, one of your answers, remember on the left side I had plus or minus 50? And I had it equaling x minus 50? Well, if I add 50 to the plus, I get 100. If I add 50 to the minus, I get 0. So my two intercepts were 100 and 0, not 0 and minus 100.
Okay.
So it was just that last mistake that we made in solving that last part. So it ended up the perfect way to draw it was with one of the x-intercepts at the origin. And believe it or not, that's almost always true. If you want to draw a model of a bridge with a support system that's in the shape of a parabola, make the x-intercept at the origin. That's just a good way to draw your model. and everything works now. In other words, we know our vertex is at 50, 120. We know our x-intercepts are at 0 and 100. We know everything about that bridge. Maybe. Determine the width of the bridge support at the level of the bridge deck. Part C. What's the distance of my pink line?
100 feet.
That's the width of the bridge support. In other words, the black parabola is the bridge support. They want to know how wide is it at deck level. Well, it goes from 0 to 100, so that's pretty easy. So the width is 100. What does the vertex of the graph represent in the context of this problem?
The height of it?
The middle of the bridge support, I suppose. Okay. I don't know what they want for an answer on that one. It's the middle of the support. Our picture tells the entire story. I guess, what does the vertex represent? Where the greatest load is on the support? In other words, if you were looking at it from a physics point of view and you were trying to figure out where is the greatest force on that support, it would be at the vertex. I think. Okay. Actually, I don't know that for sure. That is a physics problem. It's not really a math problem. So the answer to this math problem is the center of the support, I suppose. How high is the support when you are a quarter of the way across the bridge? Well, a quarter of the way is 25, correct?
Yes.
What's that point?
25 feet high.
You got to fill it into the equation. It's not going to be as simple as that. In other words, the equation of this parabola is that complicated looking thing there. And they want to know what h of 25 is. That's the question, is what is h of 25?
So h of 25. So h of 25 equals 6 over 125 times x minus 50 squared, or wait,
x is 25. So x 25 minus 50 is 25, negative 25 squared, plus 120. So whatever that number is the answer. And it's not as hard as it looks, because 25 squared is 625. So I can replace that with 625. Now 625 is divisible by 125 exactly 5 times. So I got 5 times minus 6, which is minus 30, plus 120, that's 90 feet. If the height of the bridge support was 120, then this distance is 90. And that's what they're asking. When you're a quarter of a way across the bridge, if you were halfway across the bridge, you'd be right there. So if you're a quarter of a way across, then x is 25. And you can begin to see the advantages of putting this bridge and bridge support onto an XY coordinate system, because it allows you to solve it as a parabola on an XY coordinate system.
Okay.
Which means you can do the whole thing algebraically. Whereas it would be a lot harder if I didn't set this up at the origin. If I had the bridge like this, my math's going to be a lot harder. My x-intercepts won't be there. First of all, I really don't have any choice. My x-intercepts are whatever they are from that function. So I don't really have any choice on how to draw the picture. I got to draw it like that. But the very first part of this problem is draw a picture to help solve. Well, you can't draw an accurate picture right off the get-go without solving it. So you kind of have to draw an approximate picture, and then when you solve it, you see where all your key points are, and then you can replace the bridge support and the bridge onto the XY coordinate system more accurately.
Okay.
Okay. So that's it for today, I presume?
Yep. That's it.
Demetrius, I'll talk to you on Thursday. Happy Halloween.
All right. Thanks. You too.
All right, bye-bye.
Bye.